Pre-lesson 3.8, functions, day 2, page 101. Kind of a sense of accomplishment. Today, we're going to continue. As you can see, it's a day 2 lesson, so we're going to piggyback the previous lesson, in which we talked a lot about domain and range. What's domain? Your x values. What's your range? Your y values. So, today, we're really going to focus on domain. Now, there is a little challenging problem up at the top, okay? That's not going to be something I talked about in the pre-lesson. And then there's some unique little problems at the bottom. We'll talk about those. But really, the heart of today's lesson is right in here, example 2. But it's got 6 different examples in example 2. That's what I'm going to really try to focus on right now. So the question is, if you look at the instructions for example 2, it says state the domain of each function. So really we're concentrating on this word domain. So you have to know, okay, wait, what's domain? Is that X or is that Y? Remember the memory tool I gave you in the pre-lesson. What comes first in the alphabet, X or Y? Well, X does. And you got domain and range. Well, domain starts with D, range starts with R. You can match those up. D goes with X, R goes with Y. All right, there you go. Throw that in for free. So, in the world of math, you have to bring along with you like two luggages, briefcases, 2 rules that are just constantly you're on the hunt for, and they pop up once in a while. And that is things that just cannot happen in the world of math. One of them is right here. The other one is right here. We'll talk about that, okay? So, 10 divided by 2. If I said, hey, what's 10 divided by 2? You would say, well, that's 5, Mr. Cleefish. Why is that a math? No. It's not, okay? That's a math yes. But here's what I'm trying to teach you. How do I know this is true? Well, if I multiply these together, wouldn't I get 10? Just a little rule, a little nugget. How about this one? 0 divided by 10. I bet you a lot of you would say, yeah, that's 0. Well, how can we check it? Well, is 10 times 0 equal to 0? You'd say yes. So this is yes. This is yes. You know where I'm going, don't you? If I made this like a race, first one to show me the right answer gets a prize. And I said, what's 10 divided by 0? I could get probably 95, maybe 100% of the class to say 0. And then we look at that and let's test it. Does 0 really even go into anything? No. This would be saying that 0 times 0 is 10. No. It is mathematically impossible. You may never, ever, ever, never have a 0 in the denominator. That is a mathematical impossibility. So number 2, in this section of math no-nos, if the question's asking you, what's the domain, you have to know, hey, they're talking about my x's. Now remember what we said about f of x? F of x equals y. So it's not talking about this, it's talking about this side, okay? So it's really saying, hey, talk to me about this. What can't x be equal to? Well, you'd have to ask yourself, I know that you can never, ever, 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 ever have a 0 in the denominator. So what value for x would cause the denominator to be 0? Well, x is -2 is what we cannot have down in the denominator. Anything else is fine, because you can have anything in the denominator other than a 0. So in this problem, my domain would be x can't equal -2. It's the only thing that x can't be in all the land. All right, now let me throw this little thing at you. What if it had something like this? X minus 3 over x plus 2. Where's the math no-no? The math no-no is you can never have a 0 in the what? Denominator. So even if they throw some stuff at you on the numerator, It's like it's not even there. You can concentrate on the denominator. It's kind of a strange little math problem, but be prepared for a few of those. Okay. No, number 2. Now, I might go a little too deep with you, but I want you to understand square roots in the same process. So you guys have been dealing with square roots before. I bet you if I said, hey, what's the square root of 4? You guys would quickly say 2. But to help you understand today's lesson a little bit, I want you to understand what square roots really are. Square, think about that. You say square root. What does that mean? Well, first of all, it does have to do with a square. See, I've drawn one. What this is saying is if the area of the square is 4, this guy, it's asking you what is the length of one side? Well, it'd be 2. Well, how do you know that? Because 2 times 2 would give you my area, 4. You see, that's why the square root of 4 is 2. It's asking for the length of one side of a square. Okay, now, what if this was the problem? This problem is actually asking you, what is the length of one side of a square if the area is -4? Do you see a problem with this? How can you have a negative area? Not possible. Now, I know some of you have probably been taught like imaginary numbers. That's not what we're talking about right now. We're talking about the area of a square. This is a mathematical impossibility. That's why to solve those, you need to use imaginary numbers. That's for another day. But that's why they're called imaginary numbers. They're not real. They don't really exist. But anyways, so the rule is you can't have a negative under a square root. Now, some of you are like, aha, so you can't have a negative, so this is impossible. No, this is not the same as this. See, we don't know what x is. So what if x is 10? See, then we'd have 3 times 10, which is 30. 30 minus 3 is 27. That's okay to have a square root of 27. So we're talking about all of this. All of that can't be negative. So 3x minus 3 can't be negative. Now, I forgot to show you something, but square root of 0. I know this is a weird one, but that's just 0. So this is mathematically possible, even though it's kind of weird. Like, how do you have a square with area 0? I don't know about that, but mathematically it works. It's considered to be okay because 0 times 0 is 0. Anyways, this is okay. So I'm saying this can't be negative. Now we're going to play a little trick on our brain because we don't know how to say this mathematically, but we can say that this stuff, 3x minus 3, if it can't be negative, then if we think about a number line, there's 0, and here's all my positives, and here's all my negatives. What we're going to say is what it can be. It can be all of this, including 0. So we're going to say, all right, this stuff can be greater than or equal to 0. And now we've created our own little math problem. We're just going to solve it. 3x is greater than or equal to 3. Divide by 3 and I get x is greater than or equal to 1. Now let's check into this. Pick something greater than 1. Okay, 2. 3 times 2 is 6. 6 minus 3. I don't care what it is. I'm just talking about the domain. Pick something not greater than or equal to 1. 0. 3 times 0 is 0. 0 minus 3 is -3. The square root of -3 doesn't work. This is the answer for my domain. Remember, domain has to do with x, but you kind of have to think about what can't this be. It can't be negative, therefore it has to be greater than or equal to 0. Now, students who look for rules, they say, hey, does that mean every time we have one of these, we set it greater than or equal to 0? And the answer is yes. For you rule lovers, there you go.